Hello children. Next, we'll continue with refraction. I'll just give one example for refraction. We know that when a coin is dropped inside a pond, it appears to be raised. Or a pond with water, filled with water, appears shallow than its actual depth. This is because of refraction. So let us consider that an object is inside the pond and how it appears raised. Let us see from this figure. So let us calculate what is the real depth and the apparent depth. Real depth is the actual depth and apparent depth is it appears to be raised. Real depth and apparent depth. Now let us consider a tank. So this is filled with water and let its refractive index be represented by mu W, which is a denser medium, and this is air and the refractive index is represented by mu A. This is the rarer medium and this is a denser medium. Now let us consider a point object is placed at the point O. A ray of light from O, when it reaches the surface, it has to get refracted. But we know that when a ray of light travels normal to the surface, it has to go straight without bending. And this is the only angle at which Snell's law is not obeyed. We know Snell's law is mu is equal to sin I by sin R. But for this ray which is travelling normal to the surface, Snell's law is not obeyed. Why? It does not bend. So you must understand this. Whenever a ray of light travels normal to the surface to the second medium, it goes without any deviation, which means it travels normal to the surface like this. So the ray is traveling in this way. Now let us name it as OA. Here refraction takes place but it does not bend. It goes along the same path. Now consider another ray of light from O. O is the point object inside the water. Another ray of light from O. So when it reaches the surface, it has to get refracted, which means that it is bending. When this, I'll mark this as B. When this refracted ray is extended, it appears to come from I. So this is because of refraction. So the object which was at O, it appears raised and now it is at I. And this distance, I'll mark this as A and A dash. This distance OA is called as the real depth. Is called as the real depth. And this distance IA is called as the apparent depth. Is called as the apparent depth. So a coin appears raised, it is only because of refraction. Now this is the incident ray and this is the normal at this point. So since this is the incident ray, this is the normal, this is the incident ray, I mark it as I. But these two are alternate angles, so this is also equal to I. This is the refracted ray and the normal, so I mark it as R. When two lines are cut by a transversal, since this is R, this is also R, which are corresponding angles. Now from this triangle OAB and AIB, we calculate what is sin I and what is sin R. So sin I from this figure, sin I equal to opposite side by hypotenuse, that is AB by OB. And similarly sin R opposite side is AB and hypotenuse will be IB. So we have written what is sin R and what is sin I. So I'll just find out what is sin R by sin I. I'll just write it as AB by IB into OB by AB which is equal to OB by IB. Now, let us apply Snell's law at the point B. Now, when you apply Snell's law, product of the refractive index, that is mu A, and in the rarer medium we have sin R, is equal to, in the denser medium you have I and refractive index is mu W. That's equal to mu W into sin I, or sin R by sin I equal to mu W by mu A, which is equal to mu W. The numerator will come below, and so we write it as mu WA. When you compare these two equations, both are sin R by sin I, sin R by sin I. So we can equate the two equations and write mu W by mu A equal to OB by IB. Now we make a small assumption over here. If the angles I and R are very small, let us consider the point B to lie very close to point A. In that case, OB can be approximated to OA and IB can be approximated to IA. So this equation, I write it as mu W by mu A, which can be written as mu WA, is equal to OB is written as OA by IA, where OA is called as the real depth, and IA is called as the apparent depth. Real depth can be represented by X, apparent depth can be represented by Y, and this can be written as X by Y. So this is a formula relating real depth and apparent depth. That is mu WA equal to X by Y. X is the real depth and Y is the apparent depth. With this, we complete this formula.